how's everybody doing out there? AP Calculus. Hello, Thursday afternoons. You notice that it seems like every Thursday afternoon the weather is just not really perfect because God wants you to watch AP Calculus on Thursday afternoons. This is true. And doesn't want you to tempt you with beautiful weather outside. It's muggy. It's perfect time to be inside. And everybody wants you to be at the prep session this Saturday at North Dallas High School. And I'll be there, and so will the great calculus teachers in the district will be there to prepare you for the AP Calculus exam, which is in how many days? 35 days! 35 days, which is divided by 5 weeks. 5 weeks, man. You should be just about finishing up and starting your review in about a week or so, I would think, and that is just great stuff. You know, that reviewing for the AP exam, the last 4 or 5 weeks is just absolutely key. You're going to get, all the students are going to get review materials of old practice exams this Saturday. You'll get them, we're going to give them to you. You'll have binders to put them in. You go through those exams, you'll have answers to everything. You'll be in real good shape. Who's out there, first caller? 972-52123. Is this Ann?
Yep.
How you doing?
Good, how are you?
Pretty good. Here you are right here. Hey!
Yep.
That's you, yeah. You can be a little more excited. Hey,
Yeah.
do you know that Ms. Brzezinski is one of the three? Do you know Ms. Brzezinski is one of the 3 finalists in the district for Teacher of the Year?
Yeah, that's cool, isn't it?
It's very cool. I heard you're not going to vote for her. Why aren't you going to do that?
I am.
I'm just kidding.
I didn't know students got to vote.
I know, they don't. I was just kidding. Hey, let's take a look at this problem. This is a pretty tough problem.
Okay.
It's a pretty tough problem to start out.
Okay,
Now take your time. And this is a graphing calculator question if you choose to use it.
Okay, so, wait, can you zoom in on it a little?
You can't see, really? Okay.
Okay, cool. Great. Okay. Okay, first of all, you gotta find, the thing for, 8 to the x dx, which would be, you need to integrate that first part so that you can,
What is the integral of 8 to the x dx?
would be, 8 to the x, natural log of 8, or something like that.
I think it's 8 to the x divided by natural log of 8, isn't it?
Yeah, 8 to the x over natural log of 8. Yeah, I remember. Okay.
Okay, but you know what's going to be a problem if we do it like this? If you plug this into the calculator,
it's going to
8 to the 1,000, it's going to go crazy. So we can't do that.
Okay, we could...
Or maybe we can. Let's try to do it this way.
Hey, I got an idea.
You do?
Couldn't we just, this may take a while, but run it from 0 to 500, and then from 500 to 1,000?
You're right. That will take a while. Let's do what you said, 8 to the x divided by natural log of 8. Let's see if we could simplify it to 1,000. So it's minus 8 to the 1,000 divided by natural log of 8.
So that
minus 8 to the a over natural log of 8. So they cancel out, right?
Right.
So
right. So it's just
it's 8 to the a over natural log of 8.
8 minus 1.
Right, is equal to 10.4.
Oh, that's cool.
Well, hold on, I'm going to show you even a cooler way to do it.
Yeah.
11.4. Now, how would we solve this from here? How would you solve for a?
You forgot the divided by natural log of 8.
Times natural log of 8. How would we solve for a?
You would, take, I don't know, do something like natural log sub
You can
8.
take, that's right. A calculus way of doing it is taking it the natural log of both sides, right?
Yeah, but that would do like the power of 10, but then it'd be like natural log with a base of 8, right?
Right, and so therefore this is a natural log of 8. So the answer is a is equal to all this, the natural log
Oh yeah,
of
I forgot
11.4
about that. Hang it up, hang it down. Okay. Yeah.
times natural log of 8.
Yeah.
All that divided by natural log of 8. You see that?
Wow.
So that's one way to do that, and that's easy to plug in your calculator. You take, this times this,
Yeah.
take the natural log of it, divide by natural log of 8. That's one way to do the problem, okay?
Okay.
Let's, and what we're going to do is I want somebody from the Jaguars to call back and see if they could do this problem a completely different way without using this type of integral at all. In other words, how could they do it using the graphing calculator?
Yeah.
You have somebody try to figure it out, okay, and call back.
Okay.
All right?
Okay.
Okay.
Goodbye from the big cookie. Bye.
What? I'm the big cookie?
Yeah.
I'm the big cookie.
Well, no, I said goodbye from the big cookie.
Goodbye from the big cookie, and make sure you're going to be there Saturday, right?
Yeah, I
Okay.
plan on
We'll
it.
see you Saturday.
Bye.
Allison Hall, the great Allison Hall from the Carter Cowboys.
Hi, Mr. Flight.
The great Allison Hall from the Carter Cowboys. Yeah. Who's that? Who's that in the background?
That's Patricia Garrett.
Who?
Patricia Garrett.
Patricia.
She's new.
Yeah, but she knows how great you are. Hey, I got a question for you. First of all, were you able to follow that last problem at all? That's pretty tough.
Yeah, I can follow it. But
We're gonna
it
show-
was tough.
We're going to show you a different way to do that problem in a few minutes. But let's. How about let's try this problem right here? Excuse me.
Okay. Okay. Yeah. What? Okay. You have to integrate both terms separately, right?
Well, you tell me what to do.
You multiplying, right?
It's x squared times e to the x cubed, and I want the integral from 0 to 2.
Okay. You have to fix it.
I have to fix it. All right. How do I fix it?
You need to get a 3 on the outside. I mean, not on the outside. You have to multiply times 3x squared, and then 1/3 on the outside.
Okay. So you have 1/3 here, right?
Mhm.
From 0 to 2, and you have
3x squared
3x squared.
e to the x cubed, and then you have e to the u du.
Very good, because this is the u, and that's your du, right?
Mhm.
That's excellent. So it's 1/3. Oops. It's great that you saw that right away. That was really very good, Carter Cowboys. And then the integral of e to the u is what?
E to the u.
Which is just e to the x cubed. So you plug in 0 to 2. What's the answer from there?
E to the 1/3 e to the 8 minus 1/3.
Very good. I try to trick you on that with the, when you plug in 0, e to the 0 is 1, right? Minus 1/3, which is 1/3 times e to the 8th minus 1 either way, right?
Mhm.
Allison,
Mhm.
fine job.
Ding ding ding.
Call in again. I'll give you a harder problem, okay?
Okay. Bye bye.
Hey, great job. See you Saturday. You're going to be there Saturday, I hope.
Okay.
Right? You're going to be there Saturday?
Sure.
Okay. You know about this, right?
Yeah.
Okay, cool. All right.
Okay. Bye.
Bye. Butters.
Hi.
Butters. Okay, Butters.
Give me something easy for warm up, okay?
Easy for warm-up. Okay, here
Yeah,
you
I
go.
need something easy.
Not that easy. How'd you like that first problem? That wasn't that easy, was it?
What first problem? Oh, I liked it. It was good.
Yeah, I'm gonna, there, and somebody from Molina is going to call back and show a different way to do that. Hey, Butters, how come you didn't try to answer the question of the week?
Because I'm lazy. Don't ask me.
Butters, you could have got some $10 on Saturday.
I'm lazy.
You going to be there Saturday, Butters?
Yeah, I'm just gonna come to watch your presentation and I'm gonna go again.
Okay, that's, all right, that's, I think that, I'm a little rusty. I think the other teachers are probably a better choice to go to. But here, try this problem right here. Find the tangents of the curve y. Find the tangents of the curve y equals x cubed plus x at the points where the slope is 4. That's question number
Okay.
1. Question number 2, what is the smallest slope on the curve? Question number 3, at what value of x does the curve have this slope?
Okay, let's do the first one. Take the derivative and set it equal to 4.
Take the derivative, so we got y prime is 3x squared
3x squared plus 1. And then set it equal to 4.
Set equal to 4, and we got 3x squared is equal to 3, so what's the answer?
1. Positive and negative 1.
Yeah, x is equal plus or minus 1, and if you want to find the y points...
We don't have to, I mean...
Okay, yeah, and it should, on the AP exam, it'd be more specific. It would say x coordinate only or x y coordinate.
Yeah.
Okay, so we got that. What about the second question? What's the smallest slope on the curve?
We're trying to find the minimum of the derivative.
Okay, so we want to find the minimum of the derivative, and what would the
Why?
minimum...
Take another derivative.
I don't want you to do that. I want you to do it without it.
Whatever. Okay,
I want you to think about this.
it's x squared moved up 1, so it's probably going to be at 0.
And what is the smallest slope on the curve? What is the
It's 1.
It's 1, and it occurs when x is 0, right?
That's what I said, at 0.
I know. If you wanted to take the derivative, you'd see that the minimum for y prime,
Yeah, it's just x squared moved up 1.
y prime decreases and
Okay.
increases, so y double prime is negative then positive, right?
Uh-huh.
That's a fine job, fine job. Okay, Butters, and what about the third question?
At what value of x does the curve have the slope? At 0. We just found it out. Oh, value, plug 0 into the original, so it's 0 cubed plus 0 equals 0.
Right. At what value of x does this curve? So in other words, at the point 0, 0, the slope is 1, which is the smallest slope. And if you graph it, so in other words, if you graph the thing, it'll probably look like something like this. You probably could think
We can't see that.
Oh, you can't see it? Okay. It'll probably look something like this.
On my performance, that's the way I use it.
Where the smallest slope would be 1 right there.
Yeah.
You see that?
Because you can walk on
Well, that's beautiful.
not make it.
That's a fine job there, don't you think?
Yeah.
All right, Butters. Next time, be ready for a little harder question, Butters.
Okay.
All right. Josh.
Yeah,
What's your last name?
Chupik.
Josh Chupik from Woodrow Wilson.
Yeah,
How you doing?
pretty good.
I'm glad. What type of question do you want? What type of question would you like?
How about area or volume?
Okay. Well, you know what? We're not going to do volume this week. We're going to save it for next week.
Okay.
I was that was a request from a famous.
Then why'd you ask me what kind of problem I wanted?
I just make conversation while I was trying to think of what problem I could give you.
Okay.
It's called stalling. But anyway, all right, Josh. At what point is dy dx and dy in the second derivative? This stands for the second derivative. At what points on this curve, if this is y, at what point or points are both dy, the first derivative and second derivative, negative? I'll tell you what, for each point, tell me about the sign of the first derivative and second derivative for each point.
Okay, at A, the first derivative is positive, and the second derivative is negative.
Okay, so we got a positive and then negative, all right? I agree.
B would be, the first derivative would be negative, and the second derivative would be negative.
Yeah, I think I wanted the second derivative to be 0 because it's like here it could change from concave down, but
Okay.
but that's sort of tough to see. Okay, negative and 0. What about C?
Negative and positive.
Negative and positive, or what about D?
It would be equal, or 0, and concave up.
So it's positive.
Positive, yeah.
And I probably should put pluses and minus, but that's okay. And then what about E?
Positive, positive.
Positive, positive, right? So the answer to the question is none.
Right.
They're not, none. I mean, if this is truly changed from concave, that was too easy for you, wasn't it?
It's pretty easy.
Pretty easy. Okay. So none of the points. Because you're Josh Chupek, let's try this one real quick.
Oh, great.
You remember those? Basic formula, bud. Basic formula. Spit it out. Spit.
I know I can't. I got no clue. The derivative of u over a squared plus u squared.
Hey, Over what?
A squared plus U squared, maybe?
It's over the square root of 1 minus U squared. But you know what, Josh, something really important. You're going to do pretty well. You're really smart, and you have a really good teacher and good class.
Oh yeah, we have requests to see Irby's picture.
Okay, well, I'll show you the next Woodrow person call in. But you know what? Something really important. First of all, you're going to be there Saturday at all?
Until noon.
Okay, that sounds good. You're going to get a review packet where all old sample tests, and if you go through that, you're all set, and there's answers to everything. The other thing you need to do is you need to memorize that formula. There's going to be a formula sheet that you're going to get, and you need to memorize it. Because you could have a question like this on the AP exam, and this is supposed to be easy. You just have to memorize some formulas, and the answer to this is 4x over the square root of 1 minus 4x to the fourth, okay?
All right.
So it's just, you're right, it's the integral, it's u prime all over square root of 1 minus u squared is the derivative arcsine of u. All right, so just memorize those formulas, all right?
Okay.
Hey, when another Woodrow person calls in, we get Irby.
All right. Thanks.
Russell!
Hey, what's up?
Hey, no, what's up with you?
Nothing.
You think you could do that problem that I talked about?
No, nobody else wants to call in, so I called.
Well, what do you mean? Okay, let's take a look at that problem again here. I think it was the integral from 0 to 1,000
Dx.
of a to the x minus the integral from a to 1,000 of a to the x dx is equal to 10.4. So what do you think we could do if we had a calculator? First of all, a calculator is too much, but hey, just in general, what is the integral from 0 to 1,000 minus the integral from a to 1,000?
Isn't it like two different areas?
Yeah, well, how about this? Let's do something like this. The integral from 1 to 4 of some function minus the integral, I'll make it 1 to 5, minus the integral from 3 to 5 of some function. What do you think the answer to that is? What does that simplify to?
Isn't it from...
Think about it. The area from 1 to 5 minus the area from 3 to 5 would be equal to what?
1 to 2, right?
1 to what?
1 to 2?
It'd be 1 to 3 because
Oh, okay.
you have the area from 1 to 5, whatever this is,
Uh-huh.
minus the area from 3 to 5. So if you take this whole area from 1 to 5 minus the area from 3 to 5, you're left with the area from 1 to 3, right?
Okay, yeah.
So what about this up here? The area from 0 to 1,000 minus the area from a to 1,000, using the same philosophy, would be what?
Integral from 0 to a.
Very good. So the answer to this is this 0 to a of a to the x is equal to
10.40.
10.4. So if you realize that, then you know what you could do if you forgot this integral, and this is a really obscure integral. If you forgot it, once you had your calculator, this is what we're trying to find. We want to know 0 to what? One way to do it, this is sort of a cheating way to do it,
I
but
can hardly see it.
you can't
It's
see
dark.
it.
There you go.
Comma x, comma 0, comma, let's just try, if there's multiple choice, we could plug in the answer, but let's just try 5. And then we want the answer to be 10.4. Well, that's way too high. So you could go second enter and get that back, and let's try 2. All right, this is just so we could, and then now let's go second enter again, and let's try 1. All right, and we're trying. So we need the 1.5. If this was an old multiple choice question, so you can imagine how easy it would be. You just plug in the multiple choice answers to figure out which one it is. And so you could see that the answer, when you plug in 1.5, comes out to be 10.400. So the answer is A would be equal to 1.5.
Okay.
That's one way to do it. And you also could have done it on the graph. When you could have done 8 raised to the x and then gone zoom 6 and try to find out, when the area from 0 to what would be equal to it, and then you could have just sort of found out the area that way. You know what I mean? So we're using so that's a good way to use the graphing calculator if you understood that 0 to 1,000 minus 0 to a is equal, minus a to 1,000 is equal to 0 to a.
Okay.
Pretty exciting, don't you think, Russell?
I'm scared now.
What?
I'm scared now.
Why are you scared?
If they're gonna have those kind of questions on the test, then
That's a really, that's something really, a great question. That would be, without a doubt, that would be, if there's going to be, 40 multiple choice questions, that would be one of the 5, of the multiple choice, one of the 5 hardest questions you'd have. And you know how many you have to get right on the AP exam to at least get a 3? I mean, if you get less than half right, and you get 2 out of the 6 free response problems, you're going to get a 3 or maybe even a 4.
no, a 5.
Well, I mean, saying if you got half the
But
multiple-
Jaguars are 5s.
Right, but I'm saying if. So this question, don't be scared, Rocio, because this question would be one of the hardest multiple choice questions on the test, okay?
They want to see a picture. What picture?
I'm looking for it as we were, I'm looking for you.
What picture?
With Rocio!
No, not mine. The class.
Oh, the class?
Not mine. The class.
Nice picture of the class.
There we go. See, Jaguars. 01.
Jaguars 01. All right. Hey, great job, okay, Rocio?
Bye.
And,
Oh.
bye. You're going to be there Saturday, right?
Huh? Yeah.
Okay, see ya. Casey Lee Everett!
Hi.
You were one of 4 people who got the multiple choice question correctly. You know that? I mean, the question of the week correct.
I did good, didn't I?
You did well.
I did well.
Okay.
But Miss Lehman's not here, so I don't have to say it that
But
way.
Miss Lehman is always there, and don't forget that. The rest of your life, when you speak, Miss Lehman will be there.
No, she won't.
Just like at W2 Right, Miss Gage will always be there. And at Hillcrest, Miss Bott will always be there. At Spruce, Miss Walker, everyone will.
Okay, we get the point.
Hey, just for that, you get a related rate problem.
Oh,
Oh,
okay.
come on now. Actually, I'm going to give you a hard relay rate problem because that was a mean thing.
Oh, come
Hey, are you
on.
going to be there Saturday?
Yeah, I'll be there all day Saturday.
Cool. All right. Figure represents an observer at point A watching balloon B as it rises from C. The balloon is rising at a constant rate of 3 meters per second, and the observer is 100 meters from C.
You misspelled balloon, but okay.
No, well, see, that was a test in talking about English. That was a test to see.
Yeah. Good cover up, Mr. Fly.
I just lost my pen, but that's okay.
Okay.
So, spelling balloon correctly.
Okay.
Oh, wait, it's spelled correctly there.
You have to have 2 L's in there. There you go. Now it's spelled correctly.
Yeah. Okay.
Okay. All right. You know, it's been like a year since I've done this.
Well, you know what? On May 10th,
I know I have
they're
to
not
do it
going to
again.
care, Casey Lee Everett. So, look, let's try to break
Okay,
it
so
down. Let's break it down.
It's
break
a
it down.
dy over dt.
Okay, so we're looking for the rate of change in x. The rate of change in x. So what are we looking for?
dx over dt.
We're looking for dx dt. So here's the key. Here's the key. The key is right here. Ah!
Oh, God. Mr. Fly.
It's so bad. You know something? It's like it's embarrassing. I'm embarrassed for me. If you want to find dx dt, what do you have to write an equation with x in it?
Yes.
So what's an equation with x in it?
With x in it?
Yeah. What?
The Pythagorean theorem.
Okay, that's one. What would be another one?
A trig identity?
A trig identity. Okay. What would be another one?
I don't know.
Okay. Well, which one do you like?
Pythagorean theorem.
Okay, that's not bad. Let's try. Let's see if that's going to work. What are the other information? We'll see that in a second. What other information do we have?
Yeah.
If the balloon is rising at a constant rate of 3 meters per second, what does that mean?
dy over dt is 3 meters per
See,
second.
isn't this a lot easier now that you just say, what are you looking for? What do you got? And now you got this.
Yes.
So let's use that. The most popular theorem was voted most popular theorem in geometry.
Yeah, because it's nice and easy.
Okay. X squared is equal to y squared plus 100 squared, right? A squared plus b squared equals c squared. All right, so what do we do with that? We have Pythagorean theorem. Now what do we do?
Derive.
Derive. And then without help from the peanut gallery over there, what's the derivative of this?
2x
dx over dt
Excellent, excellent. 2x dx dt.
equals 2y dy dt, and that drops out, 0.
You know what's beautiful about this?
What?
And beautiful about calculus. Let's think about this for a second. This is a beautiful thing.
Okay.
And, you know, it just makes me smile. That's me. You know, you have this 100, this 10,000.
Yeah.
You're taking the derivative. And what's like another word for derivative?
Slope,
What's another word after slope? Slope is the big one.
rate,
Rate. It's the rate of change, right? The fact that if someone's 100 meters from this point, this distance doesn't change at all, right?
Isn't that nice?
If it doesn't change, the rate of change is 0.
Yes.
Isn't that exciting?
it is.
My hair's standing up. I'm so excited. Okay. This is so bad. Okay, anyway.
Yeah, it kind of is.
It's so, okay, now what do we do? We're looking for dx dt.
You move your 2x over.
Okay, well, if we're looking for dx dt, we got it if we have x, y, and dy dt.
Right.
Well, we have dy dt, we have y, how do we find x?
Well, use your Pythagorean theorem.
Yeah! Exactly. You plug in y for 50 and you use Pythagorean theorem, you find out x, right?
Right.
You plug in all the numbers and you get the right answer.
That's right.
Who is that, Rachel?
That was Emily. She was expressing her enthusiasm for calculus.
Hey, and that's what, you know, I feel the love. I feel the love. But
You
that
should.
is-
I said you should.
Okay. Well, hey, listen. Great job, and we're going to give you another good problem. Call in again, okay?
Okay, bye.
Bye.
Hello?
Susanna?
Yes?
Oh, Susanna?
Susanna.
Susanna. So it's not oh, Susanna? Oh, won't you derive for me? What is wrong with me? That is so bad. What type of problem do you want?
Oh, a real easy one.
A real easy one?
No.
Okay.
Oh, I don't care. Revolution, whatever you want.
Revolution. No volumes today. I've been scolded. No volumes today. We do volumes starting next week.
Okay.
All right.
Who scolded him? Did you scold him? No, because we
You said something relatively easy, so spit it out, Susanna. Spit it out.
Okay.
Susanna, what's your last name?
Lamont.
Oh, Susanna Lamont. How you doing?
Good, and you?
I'm doing fine. Thanks for asking.
Okay, we're going to do U substitution.
Okay.
Okay, and then 5x plus 1 is u.
Okay.
And du is 5 dx. And then... And then you... Hold on. Okay, 5 inside the integral.
5 inside the integral. 5 inside the integral?
Oh yeah, no, yeah. Now you do now you do u du.
So tell me what to write.
1/5 integral. Okay, now I know. Of 5x plus 1 or u cubed. Okay, now you do that. Now you do u to the 4th over 4.
So it's 1/5 divided by 4 is 1/20th.
Okay, yeah. And now you can. Oh yeah, now you're done.
Isn't that exciting?
Yes, very.
Susanna, remember, at prom night, do not drink and derive.
Okay. Where's my bell? Do I get a bell?
Know your limits.
How was San Antonio?
San Antonio was fine. Thanks for asking.
Yeah.
How'd you know? Never mind.
I'm stalking you.
Yeah. Did Miss Barnhart tell you?
Yes.
Hey, Susanna, are you going to be there Saturday?
Yeah.
Okay. Well, make sure you stop by and say hi.
Okay, I'm gonna come to your class.
Okay.
Okay.
All right. Bye.
Bye.
Pookie.
No.
Pookie.
There we go.
Pookie. Gosh. Well, I almost called you my cat.
Hey now.
Well, my cat's name is Pokey.
But that's one O with the
I
I
know.
at the end.
This is Alma Pacina. How you doing?
Fine. We have no teacher.
Where is she? Teacher of the year
in
doesn't
Florida.
show up.
Oh,
What's
I
that?
don't know. She's in Florida. I don't know, some conference.
Oh, she's at
convention or
NCTM in Florida.
Oh, she's
So
on
wait a minute. What dedication for the Jaguars? You don't have a teacher and you still watch the show.
because it's a grade.
Oh, it's a grade. Hey,
It's 40% of our grade.
I don't believe that at all. I believe that it's pure initiative on your
it's
part.
pure threat on our
How does she
on
know
her
if
part.
you watch it?
She's gonna we record this.
Oh, you record it and she watches it. Well, that's great. That's good to hear. All right. Well, hey, Pookie,
Yeah.
say Jaguar.
No. Okay, you're gonna have to help me with this, okay?
No, I'm not going to help you. You're going to tell me the answer in 3 seconds.
You're
1,
funny.
2, 3. Answer!
You gotta help me with this.
No. You should know the answer right now. One of the Jaguars, yell out the answer. Somebody in that room, yell out the answer.
Undefined.
What?
Undefined.
Wrong. Thank you for playing.
2x squared.
Thanks. Try again.
See?
What? Hey,
Negative 2x squared?
when Miss Brzezinski sees this tape, she is going to be very angry with you all.
Every day.
Every B-day for us.
Every B-day. Hey,
Yeah.
this whole thing,
Buying.
this whole thing there, Pookie, this whole thing is the derivative of this.
Huh?
This whole thing is the derivative of
So
that.
it's 4x.
So it's equal to 4x, right? You vaguely remember that?
Yeah. Huh?
Okay, because the next Jaguar who calls in is going to get a problem just like that.
Okay then.
All right?
All right then.
All right.
Okay.
See ya.
All right, bye.
Hello?
Hi, Mr. Fly.
Annalisa Kelp? Annalisa, you're breaking hearts all over the world, Annalisa.
What?
Well, you know, you
Oh.
yeah, I'll tell you. Who's that, Emily again?
Not Rachel.
Oh, now it's Rachel.
Because Rachel doesn't come. And you always ask about Rachel, but she's never here.
Oh, well, you know
Emily feels hurt because you never mention her. You always mention Rachel.
what? I don't blame her. I'd be ticked.
That's not kind.
Tell him Rachel's not coming this weekend.
Rachel's not coming this weekend.
Well, good.
Hey, can you do 86s?
86s?
TI 86s?
Can I do them?
Like if I go to your thing, can you help me?
Well, yeah, a
That would
little
be
bit.
pointless.
A little bit, but do you have an 86?
Yeah.
Yeah, I'm gonna probably use the 83 more. I know. I mean, I'll struggle a little bit, but I'm sure that if there's any Townview people in there, they all have 86s, and we'll help. The bottom line is you need to know how to do the problems that we're going to talk about with the calculator you have, and we'll have to figure that out. So,
Okay.
go ahead. Hey, try this problem, Annalisa Calvert. Heartbreaker. She's a heartbreaker. Oh. Pat
Did you
Benatar.
hear him? Sorry.
Pat Benatar.
Write equation for the line tangent. Okay, so derive the little thing.
Derive the little thing.
Derive the f of x.
Okay, and how do you do that?
Well, 1 minus sine x. And then raise it to the 1/2.
Okay, so what's
and then
the
it's
answer?
chain, right?
Chain.
So 1, no, Mr. Fly. 1/2, 1 minus sine x to the negative 1/2.
So it's 1/2. So you rewrote this to be 1 minus sine of x to the 1/2 power, right?
Yeah, but yeah, I wrote that.
Okay.
Yeah, 1/2, I just said that. Times
So it's 1/2 times.
1 minus sine x
Uh-huh.
to the negative 1/2
Uh-huh.
times cosine. Yeah, just regular
Is
cosine.
it cosine or negative cosine?
Just cosine.
It's just
Negative cosine.
Hey, which one?
Negative.
Negative, you sure?
Mm-hmm.
Okay. Because the derivative sine is cosine, but it's minus, right?
Yep.
Okay.
Then
So what are we doing from here?
find the slope.
Find the slope.
Like zero.
This is f prime. Okay, go ahead.
F prime of x. And then you put in 0. 1/2 times 1 minus the sine of 0 to the negative.
Wait. No calculator here.
I
Stop
don't have
that.
my I'm doing it on my paper,
Okay.
bozo.
What'd you call me?
Nothing.
Annalisa?
Yeah.
Now you have to behave, Annalisa. God. I'll tell you, the youth nowadays, no respect.
I'm gonna be nice.
No, when I'm not. This is.
You know what?
This is not to be.
Stop it. That is not nice at all. You have bad behavior.
Annalisa.
What?
Matt is heartbroken that you asked someone else to prom. Okay. Anyway, go ahead. When you plug in 0, what do you get?
Oh God. Negative 1 on top
Uh-huh.
over 2.
Over 2, right?
Uh-huh.
Okay, so when you plug in, so that's the slope. Now, how do you find the point?
Yeah, plug 0 into your original one.
And what do you get?
1.
1, right? So the point is 0, 1, and that's the slope, so it's just y minus 1 is equal to negative 1/2 times x minus 0, right?
Times x minus... Yeah.
Hey, Annalisa,
Mm-hmm.
that's a beautiful job.
Thanks.
You get a little bell.
Thanks.
See you Saturday, okay?
Uh-huh.
Bye.
Bye.
Anton!
What are you doing? Mano, where have you been? I've been looking for you.
Well, you know, I gained about 10 pounds since I sent the buffet, and
That's your wife's job.
I know, you know, that's, but yeah, that's pretty good. No, we haven't been there back, but we got a nice little picture. You know that, you know,
That's the wrong one. Miss Harmon said she lost that one.
I have the other one. I forgot to bring it. It's sitting on my desk in where I.
Are you trying to post me up, Mr. Fleischer?
You know, I just, it's such a good looking picture. I just couldn't really couldn't.
You're lost for words.
I am, exactly. I'm at a loss
Hey,
for words.
can I get an exponential growth and decay? You got one for me?
Exponential growth and decay. Okay.
Let's see what I can do with that.
Let's see if I can make one up. All right.
You're the genius.
What's that?
You're the genius.
All right. How about this will be real creative. 1980. The population in Antoi world was 25 people. In 1990, in Wayman world, population was 40. If population grows at a rate proportional to the population that is present, what would be the population in the year 2000? Now, you really don't need to know calculus for this, but using our model, let's do that.
Okay, you want to use the equation CE to the KT? Your C is going to be 25.
What is that? What is equal to CE to the KT?
P.
The population.
Population.
Okay, population is equal to CE to the KT. And what does C represent?
C represents the current, like initial.
Initial population.
Initial population.
Because you know why? When T is 0.
Zero. The rest of zero except for the C.
Right. So therefore, when T is 0, and
P
T
is
equals
equal to-
0, P is C. So C is P when T equals 0, which is initial population.
Which is 25.
So population is equal to 25 e to the KT. Now what do we do?
All right, you want to plug in, let's see, 25 is equal e to the KT. You want to plug in 40 is equal to 25 e to the K 10.
To 10K, right?
Okay, e to the K. All right,
Hey, Antoi, this is really good. I mean, this is not easy to do.
and then 40,
You're doing really well.
40 divided by 25.
1.6 is equal to e to the 10K. What do we do from here?
40 divided.
Hey, let Antoi's got it covered.
Hey, she's trying to steal my spotlight here. All right, you
Who's
want to take
she?
the natural log of both sides?
Is that Butters trying to tell everybody what to do again?
No, that's Julia Garcia who walks in 30 minutes late and still tries to get extra credit.
Yeah, right. Yeah. Okay. So take the natural log of both
So
sides.
you get natural log of 1.6 over 10 is equal to K.
Because this is just equal to 10K.
All right.
So K is equal natural log of 1.6.
Hold on, let me type that in real quick. Oh, where is it? All right. .047.
0.047. Okay, so that's equal to K. Now what do we do?
All right, now you go back to the original P equals C e to the KT. You're looking for the population in 20 years. So 40 is equal to. Wait. Population is equal to 25 e to the K 20.
Okay, so that is equal to, at t equals 20, p is equal to 25e to the, 0.94, and then e to the 0.94, if I could, I believe is 2.559 or 2.560. So p is equal to 25 times 2.560, which is
I'm doing it on my calculator right now.
which is equal to 64.
Hey, are you using a calculator?
Yes.
No, you're not. Oh, Yeah, I
I'm
just
sorry
got
to
that
disappoint you.
to
I can't do e to the 0.94 in my head. I'm sorry. But
So the population in 20 years is 64.
right in Antoy world.
In Antoy world.
You know what? You did it. You know, this is a basic exponential growth problem, and we'll give you a harder one. I'll give you a harder one next time you call because that's what you want to practice it. But the fact that you just nailed that one and did it easily, that's really impressive. So that's a great job.
So you coming to mind those? Julie says I did it with her help.
What'd you say?
Julie says I did it with her help. Since she was blurting out the answers, but that's okay. I'll call back in and do it myself.
Okay.
All right.
Hey, have a good one.
You too.
Odigo!
No, wrong. He just left the room, so
He left the
somebody
room.
else. He just left.
Who is that?
So Yesenia Rueda is gonna do it.
Who is it?
Yesenia.
Yesenia.
Yeah, hold on.
Okay.
Hello?
Hello. Remember the last problem I gave to the Jack?
Yeah.
Okay, you ready for a problem sort of like it, but not quite?
Okay.
Are you nervous?
Yeah.
You are? Well, let me give you a picture here. Let me give you a picture so you could relax a little bit here. I'm looking for it. I'm almost there. You got so many pictures here, I'll tell you.
I don't. I don't realize we have no teacher.
Okay. Well, go ahead. What do you think here?
I'm getting some direct substitution. Is that it? No, I got the answer. It's 4x. I think it is.
It's 4x.
Yeah, it's 2. Okay. So let me see. Yes, that's me. Okay.
4x.
Okay, that's
If
me.
there was an x there, it would be 4x, right?
Yeah.
But there's not an x there, so what do you think you're going to do?
Hey, Regal's back.
What?
You want to talk to him?
No. What would be the answer?
Okay, let me see. Wait. Okay, there's no X there, so.
So what would you do? What do you think you would do? Take a guess.
Well, it's 0, isn't it?
Well, if this was an x, what is the answer to this? The limit is h goes to 0 of 2 times x plus h squared minus 2x squared all over h. If that's the case, what is the answer to that?
4x.
It's 4x, because this whole thing, this represents the derivative of this.
Uh-huh.
So if this whole thing represents the derivative of 2x squared, what do you think this whole thing represents? It represents the derivative of 2x squared at x equals 3.
Oh, okay.
So what's the answer?
18.
What's 4 times 3?
12.
12.
Talk about the top one or the bottom one?
Well, see, this whole thing, if you have a number there where you think there's an x should be, pretend there's an x, take the derivative and plug in the number, okay?
Oh, yeah. Uh-huh.
All right?
Yeah, okay.
Ms. Brzezinski's going to get on you when she watches this tape.
Well, it's Regal's fault. He ran out of the room.
Hey, when, you got to catch Rodrigo, man. He's a cheetah.
Cheated.
He's a cheetah. Cheetahs are quick. All right.
Okay. Thanks. Bye.
Make a cup of tea!
Hi, Mr. Fly.
How you doing?
Fine. How are you?
Hey, how come I don't have a picture of you?
I don't like putting pictures up on TV. Dana wants to know if that guy's going to be there Saturday.
If somebody else from WTY calls in, I hope so, because maybe if it's not prom, maybe it could be graduation.
A date.
Hey, wait.
I'm sorry.
But Delbert, will you ask Antoy if Matt's going to be there on Saturday? We have somebody on WTY waiting on the line. We're going to find out for Annalisa.
Okay.
Hey, Bhumika.
Yes.
You wanted a related rate problem also?
No, I didn't.
Why did you ask that for that?
I didn't ask that.
Well, they told me you said
They're liars.
you'd kick Casey's butt.
No.
Why? We don't talk that way.
Oh, no, not volumes. Miss Arthur does not like volumes.
Hey, chill, Bhumika, and read the question.
Okay, the volume of a cone.
Miss Martha does not like volume. She already scolded me once.
Yes. Okay.
Oh, by the way, tell Annalisa that Matt is in England this week. He's visiting his brother.
Matt.
He's in England. That's what you turn down. You turn down someone who could go to England on a minute's notice. A world traveler.
Okay. Anyways, we make this problem. Anyways. Okay.
The volume. Ah! Volume! No! Okay.
Miss Arthur said to shut up.
Oh. Okay, she gets, she's going to get, well, now, see?
Oh no!
Okay.
Okay. The volume of a cone.
Now, what we do is, see, that's what happens. That's what happens. Now,
My inspiration has a mustache.
your inspiration has a little too much estrogen. Okay. All right, and that's biology. Hey, we're like interdisciplinary.
Testosterone.
Oh, whatever. I don't know. Okay, how do you do this problem?
It's going to be dv over dt is equal to 28. What's that thing? Pi.
Yeah, that's good. All right. All right, 28 pi.
And then at the instant when okay, r is equal to 3. Its volume is the volume is 12 pi, and the radius is dr over dt equals 1/2.
Dr dt equals 1/2. Okay, what do we want to know? What are we trying to find?
This is a dh over dt.
We're trying to find dHdt. So if we're trying to find dHdt, we need to write an equation with what in it?
The height.
We need to write an equation with the height in it. So, what equation hint do you think we need to,
I don't know.
what's the volume?
Volume of cone.
What's the volume of a cone?
I don't know. 1/3.
Hey, Bhumika.
Yes.
You got to memorize that formula sheet, okay? The
Okay.
AB formula sheet, it's pi r 1/3 pi r squared h.
Okay.
Okay, so if that's the volume, and we want to find dHdt, what do we do now?
Derive.
That's right, derive. So what's the derivative of this?
It's going to be 2/3 pi r times r dr over dt, and then it's going to be a product rule, isn't it? Okay, dr over dt,
Okay.
and plus,
Yeah, times h. You did the, it's the second times the derivative of the first plus the first times the derivative of the second. What's the derivative of the second?
hold on, dh,
dHdt, right?
right.
Okay. So to answer the question, we need this. We're looking for dHdt. We need r, we need h, we need dRdt, we need r. Well, we have dVdt,
Right, it's
we have r, we have dRdt. Hey, how do we find h? We don't have h. We're in trouble.
do you just solve for h in the volume one?
You sure do. If when r is 3, the volume is 12 pi, you plug 12 pi into the volume and 3 in for r,
So it's,
and you'll get h is equal to 4.
okay,
Okay, and then you just plug in all the numbers and solve.
okay.
Pretty exciting, don't you think?
Mm-hmm. Annalisa wants to talk to you.
She wants to talk to
On
me?
Saturday.
Okay, well, I'll be, I'm anxiously awaiting.
Okay.
Have a good afternoon. Come by. You're coming Saturday, aren't you?
Yes.
All right, cool.
Okay. Bye-bye.
Anton President! What's that?
Nothing. Julie wanted to do it, but she's not going to do it anymore, so I'm going to take over.
Well, I gotta think of a, you're giving me not much time to think of a, I thought I'd have until next week.
Give him a hard one.
Ooh, who was that?
Who do you think? Butters?
Butters, okay.
Butters.
Butters, all right, I got something here. Let's see,
Can't believe it's not Butters.
but it's not. Okay. All right, I laughed at myself. Okay, here we go. You have a savings account that has a $200 balance. I know for the waiters at Mondo, that's an insulting thing. 4 months later,
Okay.
you have $222.50.
Great. I'm banking now, huh?
If the amount in the account, and you didn't deposit anything, if the amount in the account is increasing at a rate proportional to the amount present, how much will you have at the end of 1 year?
At the end of 1 year?
Yes.
Hold on. Okay, see.
No help from anyone.
You use the same equation C to the KT?
Yeah, if anytime you see if the amount is changing or increasing or decreasing at a rate proportional to the amount that's present, that's the same formula.
Do you want me to just work it out myself and then
Well, no, I want you to tell me what to write. Well, as you're writing down, you tell me what to write down.
Okay, 200e to the KT
200e to the KT is equal to what?
is equal to the balance.
We'll call it cash.
Cash money. All right, 200e to the KT.
Where's that from, cash money? Where's that saying from?
that's like a record company.
I know, I'm just kidding. Okay, so what do we do? I'm sorry.
222.50 is equal to 200e to the KT. Then that's let's see, 22.
You didn't plug it right.
Huh? Yeah, it's e to K to the 4 to the K4 because you got to plug in the 4 for the time, 4 months. You see the T?
Oh, plug in 4 here.
Right.
Okay, all right. I got you.
All right, so 222.5 divided by 200. That's 1.1125 is equal to e to the KT.
E to the 4K.
All right, yeah, e to the 4K.
And now what do we do?
Natural log of 1.1125 over 4 is equal to K.
Natural log of both sides. You
Right.
get 4K is equal to natural log of 1.1125, which is 0.107 or 1066, either one. You can do 3 or 4 decimals. Your final answer should be in 3 decimals.
All right.
You do that and you get 0.027. K is equal to 0.027 either way. So, what do we do now?
So you're looking for 12 months. That's the time. So it's P is equal to 200 e to the K, which is what, 0.027, and then 12.
You plug in 12, right, and then you just solve from there, right?
Exactly.
So that's pretty good, right?
That should be it.
That's pretty impressive, Mr. Antoy Preston.
Thank you.
It's a fine job. You know what? Next week when I have a little more time, I'll even think of a more creative problem. I'm struggling with the creative problems off the top of my head.
That's 'cause you haven't been to
that's what you
Mondo's
get when
lately.
you're not in the classroom all full time anymore. But hey, fine job. Fine
Thank
job.
you.
I'll talk to you later. Who's that out there?
All right.
Rodrigo's back. Hello? Rodrigo?
Baby!
Do we?
He doesn't like talking.
He doesn't like talking.
No, hold on.
Okay, tell him to write.
Where'd you go?
Rodrigo.
Michael, do it, Michael.
Okay, interpreter.
Hey, if someone doesn't come in the next 3 seconds, we got someone else waiting. Come on.
Oh, he's on the phone.
Okay, I'll do it.
Michael's gonna do it.
I'll do it.
Okay.
Yeah.
What's up with the limits?
What's up with the limits here?
I don't like limits.
Ooh, boy. Right.
Okay. What is that equal to? You know, if you would plug in 0 here, you get 0 over 0. Because if you plug in 0 for h, get e to the natural log of 2 minus e to the natural log of 2 divided by h. So what is the deal here with this one?
Let's cancel out. Look.
No, what?
Look.
Isn't it?
Huh?
Isn't it another one?
Remember, hey, look, I'm going to give you guys a clue. If you have a limit, like a limit with the h goes to 0, delta x goes to 0, it's usually going to be that thing where you take the derivative of after this.
Yeah.
Okay.
And whenever you have 0 over 0, you got to do something. And if you realize that this is the definition of the derivative, then you realize that the answer to this, well, let me give you this problem first.
Okay.
What is the answer to this?
E to the x.
Because it's just the derivative of this, right?
Right.
So what is the answer to this?
E to the natural log 2.
It's e to the x, and you plug in natural log of 2, which is e to the natural log of 2, which is equal to what?
2.
Very good. And that's the answer to that. Isn't that easy?
Yeah.
There's a little reminder on the definition of the derivative, which almost every single AP exam, as far as I can recall, has at least one multiple choice question like that.
Okay.
Okay. Hey, thanks for calling. See you Saturday.
All right.
Butters is back.
Yep.
All right, Butters, you ready for a tough one?
I don't know.
You're getting a tough one, Butters. I'm not even sure I can do this one.
No, I've been lazy this week, so I don't know if I can
Butters,
do
Butters! Chill, Butters, Butters.
it. Ooh, nice.
Yep. Hey, Butters?
What?
Butters?
Yes?
I don't think you can do this one, Butters.
Okay. If you think so,
Hey, Butters?
yeah.
You get a special surprise. You get free pizza Saturday if you can do this problem.
I get free pizza if I do it right now. We all get free pizza.
I know. Hey,
Why are you
Butters.
being so mean today?
I'm not being mean. Butters,
Yes.
hey, give it your best shot.
Okay, let's try to factor the bottom first.
Whoa. Are you serious? Who told you that?
I'm smart like that. What do you think?
Someone told you that.
No. See,
So we factor the bottom.
we get net log of x minus 1.
Wow. Okay, what do you do now?
Now I'm
Well, that
lost.
was the hard. Now you're stuck. That was the hard part.
Hold on, let me think. Can we also do it? I know 1 over x is going to be the derivative of something. It's supposed to be the chain out from something, so wait.
Chain.
Do not sing. No, oh my god, you're singing the song. Can we try some U stuff?
Hey, Butters,
Yes.
I'll tell you what. You try this. I'm going to leave this here. You try this. You got like 2-3 minutes. If not, you can give me the answer on Saturday or next week. But we're going to put you on hold. We're going to go to another caller, okay?
Okay.
You give it a couple minutes.
Let me just write it down first.
Okay. Hello?
Hello?
Carter Cowboys?
Yes.
How you doing?
Just fine.
Are you nervous?
Yes.
So am I. Hey, this is, and you know, Carter Cowboys, you could try the question of the week. You know, last week's question, you know, you get $10. This week's winner again was Francisco Hernandez from Skyline. But you could try these problems if you go to this website for the calculus question of the week. And what I'm going to do here, I'm going to give you for the people who are watching, a little, a clue on the calculus question of the week. You ready?
Yes.
Okay, here we go. What is the answer? Now this is a bad clue, but see if you can do that problem. I was going to give it a better clue, but I just found out we only have 2 minutes. So, how would you do that?
First, I would rewrite it.
Okay, rewrite it to what?
X to the 1/2. Then integrate.
Right?
X to the 3/2
Uh-huh.
times 2/3.
Very good. Times 2/3, which is divided by 3/2. Excellent. Now what do you do?
Substituting 4 for the
Okay, and what is 4 to the 3/2?
8.
Excellent. 8, and what's 1 to the 3/2?
1.
Man, that was too easy. 7, the answer is 14/3.
Correct.
That was too easy. But try the calculus question of the week, and it's not, I mean, this is like, if you know how to do this, it's a baby version of it, but it gets a little harder, but you could give it a shot. Hey, are you gonna be there on Saturday?
Yes.
All right, Carter Cowboys?
Yes.
Okay, listen, hey, Cowboys, we'll see you Saturday.
All right.
All right, we got Butters back on. Butters, you got about 30 seconds, Butters.
Okay, is that back and forth substitution?
Well, I'll tell you, Butters,
Yes.
I want you to get the answer and take the derivative of your answer to see if you're right. Okay, I want you to do that and let me know on Saturday, or you could give it to Miss Harmon and we could check later this afternoon.
All right.
Hey, we'll see everybody on Saturday. Have a great couple days and peace.
Oh my god. Bye.
Oh my God.